Hey guys, how are you doing? Welcome to a new video in this Ashes tutorial series. So the video of today is going to be about the parameters that you can find in this pane here, in the parts pane. I have to say two things about this video. First, this is not going to be a wind turbine lecture, so I'm going to tell you where the parameters are and what they do, but not necessarily how they work. Because this would be definitely too long for this video, and it's not the purpose. And the second thing is that I'm going to go through all the parameters here, so this might be a bit boring if you just try to look at the whole video at once. So what I suggest that you do is that when you have a doubt about what a parameter does, you just fast forward until you see that that this part here is highlighted, and then I'm going to be checking these parameters, so you don't have to watch the whole video. Of course, don't forget that you can always get information on the parameters by leaving the mouse on a parameter and having this little tooltip that appears. Okay? And I'm just using the onshore template with a 5 megawatt NREL wind turbine as always. And this is version 3.16, Ashes 3.16. So if you don't have all these parameters because you have a different version, that's not a big deal. As always, if you have any doubt or any comment, if you have things that you haven't understood, just leave us a comment and we'll reply as soon as possible. Okay? Okay, so let's get started now. The first thing that you can select here is the environment. And in the environment, the only parameter that you can change is the gravity. So either you take a standard gravity, if you want to see the value of this gravity acceleration that you're using, you just click on information here and you have the value here. But you can change it to whatever you want just by clicking here and going user define. Okay, that's pretty simple. So the next one here is atmosphere, and in atmosphere we have a few parameters that you can change. If you want to see what the values are right now, you can just click here information and you find like the density, the viscosity, and so on. So these are the default values right now, but you can also change them. So for the density, you could select a density that's either user-defined, in which case you would enter the value yourself, or from temperature and altitude. So the temperature you would change here, and the altitude you would change in the ground here. I will show you how to do it just after this. So now I can put this back to default. And the next one here is the viscosity. Same with the viscosity, either default value or value that you define yourself, or from the temperature. Air temperature, I guess I don't need to explain what it is, that's straightforward enough. Okay, the next parameter here has some more option, is the type of wind that you want. So when I click this, I have a drop down menu and I can choose different types of winds. And then every time I select a type of wind, there's some options that I have here. Okay, so now I have the live type, so if I click here, then this is the option that I have. Okay, so the first wind that I could choose here was the live wind. So when I come here, that means that I'm going to choose the speed, the speed of the wind and the angle here in this area here. So when I start, the value of the wind, which I can find by clicking rotor here and going to wind speed at hub. So this value here is what I have here. Okay, so I could increase it, decrease it, and the changes happen live. So that's why we call this live. Same for the angle here. You just select the value that you want. Okay, and the only parameter that we have here is the shear. So right now the wind is uniform, which means that the wind has the same value everywhere in the whole plane facing the turbine. If I select a shear, then the value of the wind will depend on the altitude, and this variation will follow a power law. This is pretty common. If you don't know what this is, you can just check Wikipedia. It's definitely good enough for you to understand what the power law is. And the only thing that you need to know is that the reference speed, so the one that you give here, is taken at the hub. Okay. Okay, so the next wind that we can choose is uniform wind. So this does the same thing as here, but except instead of choosing the values in this box here, you will choose them from here. But apart from that, it's exactly the same. The next wind that we can choose is an IEC extreme. I'm not going to go into details here. You can check the IEC standards if you want to know more. But basically, here this gives you what type of gusts you want to choose for your wind. Okay, and that's where this event is going to start. If you want to know more about this, you can check the IEC standards, or you can play around and see how the wind looks here. But I'm not going to go into many details. Next type of wind is the sine. This is pretty self-explanatory again. I'm not going to go into too many details, but you choose a period, you choose an amplitude, and then you just get a sinusoidal wind. Next one here is the stepwise. So the stepwise can be a little bit more interesting. The idea with stepwise is that you have a wind that goes like like a staircase, I guess. Just it's easier to show you than to explain it to you. So I'll just press play. And now what you're going to see here is the values that I've selected here. So the first wind speed is 4. So you see that we start at 4. And then we have a startup duration. So the wind is going to change after 10 seconds, as you can see here. And then it's going to increase gradually until this end value. The number of increases is this that I've selected here. And the duration of each step is this one here. It's easier for you to play around than for me to explain it, so just go ahead and try. This is also useful if you want to define your own stepwise wind from file. If you want different durations or things like that, you can just right click here, and then you can export this. Export, change it, put the values that you want, and then import it again. This is quite straightforward, so I'll just let you try and find for yourselves. Okay, the next thing that we have here is the ground. So the ground, the turbine is always attached here to the ground, so this value doesn't have a very big influence in the simulation unless you choose here under atmosphere, you choose that the viscosity, that the density depends on the altitude. Okay, that's where this comes in. Okay, I'm just going to select live again so that we can keep going. Okay, and now we're done with environment. Now comes the wind turbine. The wind turbine has a little bit more stuff than the environment. You'll see just now. So if I select the wind turbine, the first and only parameter that I see here is the scaling scheme. Right now there is no scaling, so that means that the values that are going to be used in the simulations are the same values that I input, but I could choose, for example, to have a global scaling, in which case I have a value that appears here, and if I select, say, 0.5, then my whole turbine is going to be scaled at half the size. Right now you don't see it because Ashes just zooms so that the turbine always has a size that you can easily see on your screen. But if you were to check the length of these parameters, for example, going into Rotor, going into information and checking the lengths here, you'd find that these are half the ones that they were before. Okay, so I'm just going to put this back to 1, just back to normal, and see the next one. The next one here is local scaling. And local scaling, that means that for each of these parameters, or for the RNA here, I could choose a different scale. For I think the shaft also, scaling scheme. So you have, if you select local scaling here, that means that you can change each of these of the parts of the turbine manually. Okay, but I'll go back to no scaling for the time being. So that was in wind turbine. The next part that we're going to check is RNA, so that stands for Rotor Nacelle Assembly. And there's quite a few parameters that we can have here. The first one here is generator. So quite a lot of options. I will start with none. So if you select no generator, that means that there is no electrical torque applied. There is no electrical torque breaking the turbine when it's spinning, when the wind is making it spin. So that means that right now the turbine will just like spin until it reaches a speed where until it reaches a steady speed, but no power would be produced because there's no generator to produce any torque and to get any power from that. Okay, I'll just move on to the next generator type. This is variable speed, and this is a little bit more complex, so I don't think I will go into too many details, but basically now that I've chosen this generator here, I see here how I have generator variable speed, and if I want to change the values of this generator, the parameters, I go here, and that's all the parameters that we have. Again, I'm not gonna go into details because this would be a little bit beyond the scope of this video. All these parameters, if you want to understand what they do, what I recommend is that you go to the NREL, to the definition of the NREL wind turbine, because this generator is based on this turbine. And this, I will put a link in the description, but this is what you have here, okay, where they explain what how this generator works. Okay. So otherwise you can always, you know, just use these values by default or just play around and see what happens. Okay, the next generator that we can choose is an induction generator. This is a little bit simpler, and again, you know, this is not an electrical machine course, so I'm not going to go into details, but you have some typical parameters for an induction machine here, so just play around, select the one that fits your model, and that should do the trick. And again, here we have some more generators. So you could have a permanent magnet synchronous generator axial, or permanent magnet synchronous generator radial here, and all the values are explained here. These values, again, I cannot explain them in this video. This you can get from either a lecture or a book or something. Next one that we can choose here is PID controller. So basically what that means, so you can come here, I select PID controller, and what that means is that I'm going to select a rotational speed for my generator and select the gains, the coefficients, the PID coefficients that can help me reach this point. Okay. Next point here is the live generator. So this means that I'm setting the torque of the generator here, and that's it. Okay, I will come back to the variable speed one because that's the one that's defined by NREL, and that's probably the best fitted for this turbine. Next thing that we have here is the transmission. So you can choose to have a direct drive wind turbine, so that means that there's no gears between the rotor and the generator, or you could have a geared wind turbine. So if you select gear, then you have this little thing that appears here, gearbox, and then you can select the gear ratio that you want. Right now that's 97 because that's the one that's specified by this for the NREL 5 megawatt wind turbine, but you could change that to whatever you want. And you can also select from generator, and then the value is determined by the generator that you have. Okay, so I'll get back to gear, and the next thing that you have here is the blade pitch. So you could choose either to have a PI controller to calculate the pitch angle of your blades. So again, if you select this, you'll find the values here, PI controller. These values again they're not complicated, but there's no point in me explaining why all these values have been chosen. This you can find in the specification of the NREL turbine that I will again put in the description of the video, but this is the same at the same place here. This was the generator, and I think that a little bit lower down you have some stuff about the pitch. So if you're wondering about these things, you can just check this this document that I will put in the description. Okay, but the next option that I could choose for the blade pitch was to have it fixed. So then that means that whatever it starts with is going to stay for the whole simulation. And to select the value that the blade pitch is going to be, you go here, as was in the previous video, you go here, you go to initial conditions, and then you select a pitch angle value, okay? And this value is going to be fixed for the whole simulation. And the last one that you can have here is to choose it live. And again, live, it will appear here. and as the simulation is going, you can change the value here. Okay, so I'll just put this back to normal. Tilt, yaw, I guess these things you might know what they are. If you don't know, you can try and see what happens when you select a different tilt or different yaw. But at least it's important that you know that that's the place where you can find them. And here, external control, that's in case you have developed yourself a controller for the wind turbine, so you've written in a DLL, it has to be in bladed style, then you can select it from here. So right now I have not defined any DLL, so there's no DLL that can be found, but if I had one, then I would just click here and then select my DLL from here. Okay, but for now I can just go back to no DLL and start again with my wind turbine. Okay, so now we're done with this RNA part, so I'm gonna go to the rotor. In the rotor you can select the number of blades, the cone angle. These things, they're quite straightforward, just try them if you don't know what they are. This we saw in a different video, that's to select the blade that you want, so when I click here I get my blade database that's open, and now I can select which blade I want for my turbine. Okay, but right now I'm just gonna stay with the same blades. These are some advanced parameters. I'm not going to go into details, but yeah, this can help you change the structural properties of the blades if needed. Okay, the next thing that we have here is the hub inside the rotor. So the hub, I could select the radius of the hub. So, you know, again, if you don't know what this is, just try, and you see how this changes here. And then you can select that the mass is either from the radius, or you select it, you choose it yourself. And same with the inertia, the inertia of the hub, you can choose it yourself, or select that it's from the mass and radius of the hub. And if you open the hub, you'll see that there's not much here, but there's some information that could be useful at some point, so it's just nice to know that it exists. Same with the blade here, there's not much stuff happening inside the blade, but here is where you get the information about, yeah, the mass, the length, and some other stuff. This tells you about the structural elements in the blade, if you click this line here. Okay, so blades 1, 2, and 0 are the same thing, but the next thing that we can check is the brake. So the brake, you have some parameters here to select how the brake should work, but the main thing to know here is that the brake is something that is going to work here in the live controller. So if I select this now, I have an arrow that just tells me what the torque of the brake is, and now little by little I see how my turbine is stopping. And now if I remove the brakes, then little by little the turbine will start spinning again. There's different parameters that you can have that you can select for the brakes. And just you can just play around with those. At least what's important is that you know where they are. Okay, and now we're done with the rotor. So the next point that we're going to check is the main shaft. So the main shaft is what's in here. So if you don't see it clearly, what we can do is go here and remove the nacelle housing. Okay, so now this disappears, and we see the shaft here. I will stop the simulation. So length of the shaft, that's pretty simple. Horizontal distance to hub, vertical distance to hub, these things are kind of straightforward to explain. Otherwise, just always check the little tooltip if you're not sure. The position of the bearings, where the shaft is mounted, so that you can find here. Here you can lock the bearings if you want the turbine not to spin at all, and stiffness and damping of the bearings, and number of elements in the shaft. This here is about the cross section of the shaft, so it's this cross section here, and that's what these values are. Okay, the radius and the thickness of the wall. And again, here inside the shaft there's not much, but these are just like some parameters, some information that you might need at some point. The next thing that we have here is the nacelle. I'll just zoom out a little bit. And in the nacelle there's not many things that you can change, but the mass of the nacelle, here and its position, or the position of its center of gravity with respect to the tower of the top. So the horizontal offset and the vertical offset. Again, here there's not much, just the elements of the nacelle, and that can be interesting in some situations, so it's good to know that they're here. This generator, we've already seen what it was. That's this these parameters you can find in the document that I will put in the description, and the gearbox we also saw what it was already. The support structure, so that's just this tubular tower now. Maybe it's interesting to know that you can change what type of support structure you want by right-clicking on this here. So if I right-click, I can change the support structure and choose different types. Okay, so right now I'm going to put a tubular tower on the monopile. We only had tubular tower, and right now I'm going to choose this one here. So I have to restart my my simulation and press OK. Okay, and now when I open this, I see that I have two elements. So one is the monopile, that's the new one that we added, and the other one is the tubular tower. Okay, the first thing that you can change when you click superstructure is what type of element you want. The default elements are corotational. That's what you have to use if you have large deformations of your structure. For a simple structure like this, for just a tubular tower on top of a monopile, it might be enough to have linear elements, but corotational elements don't take much more time. The simulation doesn't take much longer with corotational than with linear, so I suggest that you just leave these two corotational. And the next parameter that we have is the vertical offset, so that tells you where this position is. So for example, I can select -20 here, and then I see that now this is 20 meters below the ground. Okay, this can help you have this is what you need if you want to have a geotechnical model of your turbine. We'll see a bit of that later. So now we're done with the superstructure, we can go to the monopile. The height, that's pretty simple. The material, you can choose different types of materials, and the maximum length of each of the elements of the monopile, that's what you define here. If I go to this wireframe mode here, I see this here is one of the elements, so this element is 5 meters because I selected 5 here. If I want to change this value, that's where I would choose it. I'll go back to this view here. So the diameter of this monopile you can change here. The thickness, that's the thickness of the monopile, you change it here. And here, this support type, that's what defines what this point is going to do. So you can have a monopile that's either fixed onto the ground or that is spinned. So that means that there's no translation allowed, but it could rotate around this point. And the last option is to have a spring. And then if you have a spring here, so that's a vertical spring. And if you have a spring, then you change the value of the spring here. And just go back to fixed. And now this is a tiny little bit about the soil model. So if I go back to the wireframe mode, if I zoom into these nodes here, what I see is that these things here are little springs, okay? And these springs have the stiffness that I have specified here. So they can have stiffness, rotational stiffness, or damping and rotational damping. Right now, if I do this, if I select my monopile with the parameters that I have here, if I define it with the parameters that I have here, I can only select one type of stiffness for all of these. But if you wanted to do your own values, what you would do is right-click here, export to file, and then change the values in the text file, and then import it again. We will talk about exporting and importing in later videos, but for now you can just know that this exists or try it yourselves later. And the next thing that we can see is the tubular tower. I'll just go back to this 3D mode because it's kind of nicer. So the next one is the tubular tower here. And okay, well, there's some strange thing happening because the tubular tower just should arrive all the way here. So I don't know why these elements are selected, but yeah, it doesn't matter for what we're showing. Anyway, Again, height, material, maximum of the elements, that's pretty straightforward. Diameter at the top, diameter at the bottom, and thicknesses. Okay, thickness at the top, thickness at the bottom. These values you can either select here, or as we showed before, you can export to a file, put whatever you want, and then import again. You could select a transition piece. You could say that your turbine has a transition piece. So now that I selected this, I have an element here, as you can see. This is my transition piece, and there is some elements here that you can, some parameters that you can change, which are again quite straightforward. And you could also want your tubular tower to have hydrodynamic loading, in which case you would tick this box. And right now this doesn't do anything, but the idea is that if you were in an offshore wind turbine and you had waves hitting your monopiles, typically the waves would not arrive to the tubular tower, but in case they did, you could select to have hydrodynamic loads on your tubular tower. Okay, so now we've gone through all the parameters here. The last thing that I'm gonna show you, the last thing that I'm gonna talk about, I've been showing you materials here that you could choose for your for different parts of your turbine. If you want to select your own materials, you have to go to Tools, and here you have Materials. Okay, and that's where you choose which type of materials you want. You can define new materials, change the values, and so on. And okay, I think this pretty much finishes this this video. So if you have any doubt or anything that you want to know about or anything, just as always leave us a comment, and well, otherwise I'll just see you in the next video. Bye bye.